Hello there, and welcome back to the dam. Today we will have a look at this. It's the DataExpert EXP4045, a socket 3 motherboard from 1994. It's a relative late 486 motherboard, being released just 1 year before the three main manufacturers and designers of 486 CPUs ended production, although some niche 486 production apparently remained until 2007 and maybe even beyond. A quick look at the retro web page for this motherboard reveals that it comes with a Symphony Labs SL82 C490 chipset. That is not a chipset or a chipset manufacturer that I am familiar with, but a quick search on the retro web reveals that quite a few motherboards did in fact use chipsets from Symphony Labs. Being a late 486 motherboard, it only supports 72-pin memory. At this point in time, most motherboard manufacturers had abandoned the older 30-pin memory standard that came with a data bus width of only 8 bits, compared to the newer 72-pin memory with a data bus width of 32 bits. On the subject of memory, I recently posted a video about 30-pin memory, and if you haven't seen it, I will leave a link to that video down in the description, so you can go and check out the video if you like. And a quick shout out to all of the viewers of that video. Many of you have left comments and feedback, pointing out a good amount of good points. And to those viewers, I will soon do a follow-up video on 30-pin memory, where I will take into account some of your much appreciated feedback. But now, back to today's subject, the DataExpert EXP4045. And let's start off with a look at what we are dealing with here. I bought this motherboard on eBay, where it was listed as defective, and just from a quick visual inspection, it is quite obvious that this motherboard is indeed defective. First up, we can see something that looks like a ripped off component that appears to have been a LT1085. Next, we have what looks like some kind of corrosion in the area where a battery was once installed. This kind of damage is very common on these old 486 motherboards. When this motherboard were manufactured, a rechargeable NiCad battery was installed in this position. The purpose of the battery was to supply power to the motherboard when it was not being powered on. The power was used to keep the real-time clock ticking, just like a modern motherboard, but also to power the volatile memory that stored all your BIOS configuration. Volatile as in if the memory lost all power, all your BIOS configurations would be gone, and that would be pretty inconvenient. What manufacturers of these motherboards probably didn't know at the time is that after a number of years, these NiCad batteries would start to leak their corrosive electrolyte onto the motherboard. That would start eating away any copper that it came in contact with, and thus damaging the motherboard to the point where it no longer works. And here we can clearly see that this motherboard is no exception to that phenomenon. Beside these defects, the board looks to be in excellent condition, clean and shiny, as you might be able to see on these pictures. It feels like a well-designed and well-built board of high quality. Even the quality of this socket for the CPU is probably the best I have ever seen. It feels solid and sturdy, unlike some boards that have a more flimsy feeling to it. A board like this, I would normally start by testing it before I attempt to do any kind of repair work. But in this case, I think it's quite obvious that this board is most likely not working due to the physical damage that we can see. So today we will start by attempting to repair it and then test it afterwards. So let's not waste any more time and get into it. The socket for the keyboard controller has now been removed, and we can go ahead and do an inspection of the board under the microscope to see what kind of damage we are dealing with. And as you can see, it is not too bad. I mean, there is a little bit of let me probe. You can see that the trace here has been corroded away, but that is pretty much all the damage, at least to the keyboard controller. So yeah, the keyboard controller is looking good. We only need to repair this trace. But let's have a look around. Down here we also have a broken trace that we need to repair right beside the power connector. And shit, I see a little bit of corrosion on the socket for the memory also. I really would prefer not to have to remove the socket for the memory, but yeah, I think the memory sockets we will leave alone and give them a good clean off with some deoxit, and then we can test it out. And if we have any problems with the memory, we can return to this area and remove the sockets, but I hope not. Let's continue the inspection that we had looked on. And over here we can see the ISO sockets. They are also they have also been soaked in the electrolyte and is corroded, but I would prefer also not to remove the ISO sockets, so we will also just go with a cleanup of these sockets and test them out, and if they don't work, we can come back and remove them. Just want to try and see if I can peek under the ISO socket. I'm not sure. Yeah, it's not looking the best. We might have to damn it, we might have to pull off this ISO socket as well. I see quite a bit of corrosion. That's not good. Okay. Lastly, let's have a look at the keyboard connector that is also placed down in this disaster area, and yeah, it looks to be okay. We can easily test the keyboard connector with our multimeter in continuity mode and see if we have any broken traces. On the back of the card we do have a little bit of oxidation, but not really something to be concerned about. So this is actually corroded, I think. Yeah, maybe we can just clean up these joints for the keyboard connector. But in any case, let's Let's start off by giving this a clean with some vinegar. The vinegar will neutralize the electrolyte from the battery, and then we can more easily see what we're dealing with. And now we are ready to power on the system for the first time. So let's hope this will work after we did the replacement of the voltage regulator up here, and also fixed the battery corrosion damage down here. I don't have high hopes for this to work as it is now. The voltage regulator, as we could see earlier, had been ripped off, and why that is, we don't know. It could be that the voltage regulator itself had gone bad, but it could also mean that something else on the motherboard had failed and caused the regulator to go bad. That we don't know. So this might work, this might not work, but I have hooked up the postcode analyzer and a camera so you can see the codes, and let's just try and power it on now. Let's give it some time. No beep codes so far, and currently on a code C5, and it doesn't look like it's going any further than that. So let's power on, and let's power it back on one more time. And no, it's still stuck on code C5. So let's do a quick Google search for postcode C5 on a Award 486 BIOS. And here we have some step-by-step troubleshoot recommendation from Google about Award BIOS C5 code, and we can immediately see that the C5 code has something to do with a problem with memory. So first suggestion is to check the RAM seating, and we can do that. Next, test the minimal RAM, and it's recommended to strip down the board to the minimum requirements. So we can also go ahead and remove one of our two installed memory sticks. Next up, it talks about compatibility, but I'm pretty sure that these memories we have installed are compatible, and they actually have parity, so that is not, I don't think that's a problem. Next up, check for battery corrosion, and obviously we have a lot of battery corrosion on our motherboard, so that could also be the problem. Maybe under the memory sockets there could be corrosion. And finally, it talks about inspecting the CPU and the cache chips, and we could also do that, but since we saw a lot of battery corrosion in the area where the memory is installed, I think that will be the first line of attack that we will do to troubleshoot this motherboard. And here we are back under the microscope, and at first glance the memory socket looks to be okay. I can see maybe a bent pin there, but if we look closer and maybe change the angle of the light, yeah, we can see that in fact we have a lot of corrosion on the memory sockets. And also down here at the resistor arrays, there seems to be a lot of corrosion. You can see all the green crud in the socket is oxidation from the electrolyte seeping into the socket. And this socket down here is socket 0, where we need to install the first memory stick, and it looks like this is also the most heavily oxidized socket, so that could definitely be the problem. There are also some corrosion there, and up here we have a what looks like a corroded trace. That's not good. Or maybe this is not too bad, but we can see that we have clearly some corrosion going on under these memory sockets, and also in the socket itself. So it might be a case of the socket not making contact with the memory stick due to the corrosion. But I think we will go ahead and at least remove this the socket in the socket 0, the first memory socket. We only need to install one stick of memory in this motherboard, since we are dealing with 72 pin memory sticks. So if we remove this socket and make sure that it is all oxidation free and good to go, we can test out with just a single stick of memory in this socket, and hopefully that will solve the problem. No, actually this down here is listed as circuit 1, but I think in the manual this circuit 4 here, the most oxidized, is listed as circuit 0, and is listed to be the socket that you should install the first memory stick in. So let's just double check the manual and see if that is the case. And here we have the manual for the motherboard, and actually I was wrong about the memory configuration. Bank 0 is the one closest to the BIOS chip, and bank 3 is the one furthest away from the BIOS chip. So I have actually installed the memory in the wrong socket, so that could easily be our problem. So let's relocate the memory to bank 0 and 1, and see if that alleviates the problem. I have now set up the board again, and this time I have installed only a single stick of memory in the correct socket this time, the socket 0 for the memory. So maybe and hopefully this solves the problem. So let's power on again. And no, we still get the same C5 error. Let's try with a bit of deoxide on the memory socket, since we saw that it does have some kind of some level of corrosion going on. Let me just, this can is almost out, so it's a bit difficult to use, but let's let's put back our memory stick with the deoxit and let's power on again. If I can get this postcode camera set up. And nope, we still get the same C5 error. Let's try one last time. Okay, now we get another error, this time code 83. So let's try and give this memory circuit some more deoxit, and maybe also use a brush to agitate the deoxit into the pins. Okay, I need to find another can of deoxit, so just a second. And I'm back with a fresh can of deoxit. Let's just really soak this memory socket and agitate a bit with a small brush, like this. Reinstall the memory stick, and let's hope this maybe this solves the problem. Let's power it on. Damn it. Looks like we are back on the C5 code again. I thought just for a second that we had made some progress, but now that we are back on the C5 code, we are back to square one. So deoxit and reseating the memory in the correct socket 0 didn't fix the problem. We are still on the C5 error code. So given all the oxidation that we saw under the microscope in the RAM sockets, I think next step will be to remove the first socket from the motherboard, and maybe we have a broken trace under it due to the corrosion. So let's remove the socket. After the reinstallation of the RAM socket, I tested the motherboard again, and unfortunately we still get the same error. So I started looking around some more with under the microscope, and on the main chipset I found this, and I'm not sure if it is corrosion or if it is some flux residue, but in any case it doesn't look too good, so I will clean it off with some IPA and a brush. And after cleaning, you can see that the pins appear to be in good condition, and I also poke around a bit, but I didn't find any loose pins. But I decided to go ahead and reflow both of the chips for the chipset anyway. As you can see, I have been hard at work at this motherboard for some time now, and after I found the oxidation down in this area here where the cashew chips is installed, I decided to remove the circuits, but I didn't find any broken traces, so yeah, the circuits for the cashew was probably okay, but they did have a bit of oxidation on them, so I'm gonna install some new ones, and at least I can feel good about that these circuits will from here on be brand new and functional. Since the cashew chips was not the problem, I turned back to looking down in the area where we have our RAM sockets, and yeah, I discovered that the small via that we looked at in the beginning of the video, where we could see some oxidation. A corroded trace. That's not good. Or maybe this is not too bad. I determined that that via is not connecting through. So I'm pretty sure, like 90% sure, that this tiny via between these RAM sockets is our problem. So really, to get to the via, I need to remove the second RAM socket, but I really don't like, I would prefer not to have to remove it. So I'm just gonna run a jumper wire from the back of the board and through the broken via and up to the CPU socket right here where the via should have connected to. We are now set up for yet another test of this motherboard. I have hooked up a VGA and a postcode analyzer. And as you can see up here, I have not reinstalled the sockets for the chassis chips. They were heavily oxidized, and I didn't feel like putting them back onto the board in that condition. So I have ordered some new sockets, and they will hopefully come in within the next couple of weeks. But for now, we can go ahead and test the board without the chassis chips. So let's just go and power on the board now. And it's looking good. We have a picture. Wow. Wow. Okay. Finally. So the problem probably was all along this stupid corroded via, and yeah, we saw it in the beginning of the video already, but I chose to ignore it because visually it looked to be okay, but as you can see now, and it was not okay. So to sum up, this was this was quite a job, this motherboard. It had a lot of oxidation, but in the end it was yeah, it was probably not the oxidation that we removed, but this one single oxidized via. But I'm glad that I did take it apart as much as I did. We cleaned up the memory sockets, and we have installed new sockets for the keyboard controller and the BIOS, and we will also install new sockets for the chassis when they come in. But for now, I will call this board a successful repair, and I will come back to it when I get the sockets for the chassis chips. But in any case, I hope you enjoyed this video, and if you did, don't forget to hit like and subscribe, and I will see you in the next video.